Hello class, today is lesson 8-8 in your algebra textbook. The topic is learning how to factor polynomials completely. Now you have already learned how to factor polynomials. Today they're going to be more difficult ones, and I'm going to show you how you can factor polynomials when they look more complicated. So first we're going to begin with the example 2x times x plus 4 minus 3 times x plus 4 again. So you can already see that you have the same expression right here, x plus 4 and x plus 4. So what we can do is we can write it as x plus 4 one time, and then in parentheses 2x minus 3. You see that? Because 2x is already being multiplied by x times x minus 4. I'm sorry, this should be an x plus 4. And the negative 3 is being multiplied by x plus 4 as well. So if I do the distributive property, the 2x will multiply against both of those, and the negative 3 will multiply to both of those as well. So I am done. That is my answer. I have fully factored that expression. So let's look here. I have 3y squared times y minus 2 plus 5 times 2 minus y. So these look very similar. And the only way that I can make them look exactly the same is by taking out a negative 1. I'm going to factor out negative 1, and that will reverse the direction. So what that's going to look like is, if I'm rewriting it, 3y squared times y minus 2 plus 5, and I'm going to factor out a negative 1, which means that this is now going to be in reverse, y minus 2, because 2 divided by negative 1 is negative 2. Negative y divided by negative 1 is now positive y, and I can rewrite it in that regard. So let me rewrite this again, 3y squared times y minus 2, and I'm going to multiply these. 5 times negative 1 is minus 5y minus 2. So again, if I'm looking at this, inside I have the same thing, y minus 2. So I'm going to write that down, y minus 2. And what I'm left over with, I'm going to put inside another set of parentheses, 3y squared minus 5. And now I'm done. Okay? Now, other times you're going to have even more variables. Okay? Sometimes they're going to get to a lot higher powers. We're just going to go to the third power here. And what we're going to do is we're going to factor these by grouping. The first one that we have is x cubed plus 3x squared plus 5x plus 15. The method I'm going to show you now is to do some grouping. So what I'm going to do is I'm going to just group the first two when they're in order. So x cubed plus 3x squared. Put that into parentheses. And then I'm going to group the second part, 5x plus 15. And now that I have that, in each group, I'm going to look for the greatest common factor. So between x cubed and 3x squared, I can pull out an x squared. That's the greatest common factor of the variables and the numbers inside. And now I'm left with an x plus 3. You see that? I'm going to do the same thing for my second group. I'm going to pull out the greatest common factor of 5x and 15, and simply it's the number 5. And left inside, I have an x plus 3. Look at that. I have the same thing written inside my parentheses. So let's bring that outside, x plus 3, and then whatever I'm left with, x squared plus 5. And this x squared plus 5 cannot be factored out anymore, so now I'm done factoring this group. Let's do another one. We're going to factor it by grouping y squared plus y plus yx plus x. So I'm going to group the y squared plus the y, then I'm going to group the yx plus the x. Let's pull out the greatest common factor in each group. So between y squared and y, I can pull out just a single y, and inside I'm left with a y plus 1. Let's do the same thing for the second group. I have yx and I have an x, so I'm going to just take out an x and I'm left with y plus 1. Look at that. So I have the same thing written inside my parentheses, the y plus 1. So I'm going to pull that out and multiply it by what I'm left with, the y plus the x. Okay, and now I am done with that one as well. Let's move on to our third example here of grouping and factoring it. So I would like to group this, but what I need to remember, just as in my first one, it needs to go in descending order of the highest degree going down to the lowest one if they're all the same variable. So I'm going to rewrite this first. So I have x cubed minus 3x squared plus 2x minus 6. So I rewrote this, and now I can do my grouping. So I'm going to have x cubed minus 3x squared as one group, plus 2x minus 6 as another group. Now let's pull out our greatest common factor in each group. Between x cubed minus 3x squared, I'm going to pull out an x squared. I'm going to be left with x minus 3 on the inside, plus, looks like between 2x and negative 3, I can just pull out a 2. I'm going to have x minus 3. And as you can see again, inside my parentheses, I have the same thing written down, the x minus 3. So I'm going to pull that out, x minus 3, multiply it by what I'm left with, the x squared plus 2. And I'm done. So now let's move on to something else, okay? It's going to look a little similar, but there are even more numbers and more variables in some of these, okay? So what I would say here, because this is a trinomial, I only have 3 different aspects of it. What I'm going to do is I'm going to look to see what is the greatest common factor of all 3 of these elements. And I can see a 4 I can take out, and also I can take out an x. So let's do that. 4x, and I'm going to be left with, let's see here, x squared minus 11x plus 24. All right. Now, this trinomial right here, it looks very similar to what I did in prior sections. Okay, so what I'm going to think of are 2 numbers that when I multiply them, I get 24, but when I add them, I get negative 11. And because I have a minus, a negative for the B, and a positive for the C, that's telling me I'm going to use both negative numbers. And I'm thinking, how about negative 8 and negative 3? That would add up to 11. Negative 11. So I'm going to have x minus 3 times x minus 8. And I'm done. Fully factored out that trinomial. Let's try another one. Now I have a binomial. It just has 2 elements. But I'm going to do the same thing. Let's see what is the greatest common factor in both of these. I have 3x cubed minus 12x. Between the 3 and the 12, I can pull out a 3. And between the x cubed and the x, I can pull out an x. So 3x is the greatest common factor. Inside, I'm going to be left with x squared minus 4. And you might think that you're done, but 4 is a perfect square, and so is x squared. And I know that I can write this as x minus 2 times x plus 2. I've already learned this. Okay, because when there's a minus sign, it's going to be broken into a minus and a plus. Okay, one more here. I have 50h to the 4th power minus 2h squared. Let's look for the greatest common factor. So between 50 and 2, I can pull out a 2. And between h to the 4th power and h squared, I'm going to pull out an h squared. Inside, I'm going to be left with 25h squared minus 1. And as you can see, 25 is a perfect square as well, and 1 is a perfect square, and so is h squared. So I can break this up even further. between 5h minus 1 times 5h plus 1. And I'm done. So I hope that this has helped you learning how to factor even more complicated problems. So I'm going to leave two of them for you that I'd like you to try on your own. M cubed minus 2m squared minus 8m is the first one, and also y squared plus 2x plus yx plus 2y. So come with any questions you might have to school, and I will help you out.